All right, so I'm going to swing positive right away again. Software is pretty amazing. If I think about the time that I've had the pleasure to work with computers, things have changed an awful lot. So I got my first computer in the mid-90s. I don't think that's probably that unique to a lot of people here. And at that point, the internet was small, things were simple, floppy disks were still floppy for a little bit there. But today's websites are a lot more complicated than that. What we're dealing with now, they're usually not even single websites, right? We think about going to something even like google.com. There are multiple services involved with that. And so it used to be a simple site, probably white background, black text, probably looks similar to what, if you went to a school like mine, like your professor's websites. That was the whole internet. Most sites aren't like that anymore. It's gotten complicated. And along with the sites getting complicated, so have the bugs. And this makes sense. Pretty much any time that one part of your system gets complicated, the other ones are going to scale with it. And so you kind of start to think that maybe we took these computers to a place we shouldn't, probably should have backed up, stuck to those simple sites. But that's not really fun. So instead, we could think about how we might be able to learn from bugs and use these to better ourselves, to better what our customers get from us, to better the things we can create, and how we can advance. So before I get into the more negative stuff, that was hopefully enough to bring you up after the previous announcements. I work at Google in Seattle. I work on Google Cloud. Specifically, my team owns the client libraries for developers. But before this, I've worked on things ranging from cloud services, cloud infrastructure, IDEs, and compilers. And every one of these teams had a slightly different system for handling faults, incidents, and how you conduct a post-mortem. And from that, I've picked out a few things that I think are most helpful, and I'm hoping to share that with you today. So at some point, we recognized that bugs were always going to exist in our software. And there was a point in time in which these were bugs, physically bugs, not just a word we throw around. As best I can tell, this is the first computer science-based post-mortem. If you can't make it out, it's a moth taped to a page. This particular moth got into a relay in a rather important computer to our history. And on this are also times, along with descriptions of what happened at times. And this very closely fits processes I've used before in tech. But we don't always think back to this when we do this post-mortems. We don't think of it as a historical thing, something we've been doing for a long time. We think of it as sort of a chore we do after something goes wrong. And as I said, they're not bugs anymore. Today, we have things like cosmic rays to contend with. I mean, the goal is the same, right? We want to avoid repeating our failures. But it's not quite as easy as walking into a room with a computer and seeing a bug. So the failure modes have evolved, our systems have evolved, so we need to evolve with them. And so do our systems to do these post-mortems. One of the first things I'd like to do is talk about other industries. We've had this going on in tech for a long time, right? Since the beginning of computer science, we've had post-mortems. But there are industries well older than ours that we can learn from. And there's some other industries that deal with some pretty heavy subject matter. Most technologists will never have to worry if the thing they did with software resulted in loss of life. There are corners where that's true. For the majority of us, that's not really what we're dealing with. And so I think it stands that in an environment that is that high pressure, they're going to take this pretty seriously. And so we can look at what they do and consider how we can incorporate it. And at the end of this, we realize that every mistake is just an opportunity. It's an opportunity to learn from our system, to better ourselves, and to give a better experience to our customers. So the first thing I want to look at is a group called the NTSB, the National Transportation Safety Board. This group deals with a number of different transportation industries. The most common one we think about is probably air travel, but they also deal with highways, hazardous pipelines, the rail lines, cargo shipping, et cetera. And there's an event that happened rather recently that everyone probably remembers. It was pretty bad. In Seattle, this is definitely a known thing, right? We have parking lots filled with these planes right now. But someone has to investigate this. And if you blame people too much, and you make it clear that you're about to call them out and punish them, they're not going to share a lot with you. It makes it a whole lot harder to figure out what's wrong and make things better. So the NTSB, in doing investigations of things like the 737 MAX, has provided a lot of safety recommendations, around 13,000 at this point. And the way they pull this off is by bringing together multiple experts. So in the case of air travel, we're talking about pilots, plane engineers, air traffic control systems. And by bringing all of these viewpoints together, you can get a complete picture and then figure out how to avoid faults in the future. And then you can have effective prevention, which is really the entire point of a post-mortem. So what does one of these reports look like? It's kind of boring. It looks like a very official document usually, and you get an accident number, you get some people involved, dates. Depending on the type of incident, it might have weather information if that seems relevant. Then you end up with a big meaty part in the middle, which has a bunch of factual information. I've used a former example of this. I wasn't able to use the 737 example because this only came out about a week ago. And so they usually have photos and diagrams. This one had just a lot of writing. It was unique because it's actually for two separate incidents. There were two different crashes that they were able to roll up into one. But the most important part is when you get to the end of the report. At the end of every one of these reports, there's a recommendations section. They tend to distill what went wrong at the core into a paragraph or two, and they make recommendations. This report had 7 recommendations in 3 categories, which is a lot. Most of them have 1 to 3. And ultimately, they had to do this without ever blaming a person. And they pulled this off, and it's a fine line. So for those of you in the room that have been following this story, you'll know one of the core things that happened with the 737 is during the testing phase, they used test pilots. And it turns out that when you're testing an airplane and you're looking for things to go wrong, your reaction times are much better than someone who's going about their day-to-day business flying people through the air. And so that's not really a realistic scenario to test a plane in its failure modes. You need to test it with the average pilot, with a person that is just doing their job, not someone who is waiting for something to go wrong and reacting. That's not really a great test. So how do they do this, and how do they get all these recommendations and people to participate? The big trick is that they have no prosecutorial authority. So none of the data that the NTSB gets, figures out in these recommendations, can result in prosecution of folks involved. And that's pretty critical. Without that, I would be pretty concerned about giving what essentially is a criminal deposition of what I did and what my company did wrong. And so in that open system, we're no longer worried about holding someone to account for this. We're worried about how do we prevent it in the future. And we can very much do the same thing in tech. So the next process I want to talk about is something called an M&M. And that's not after the Mars and Murray's candies that we all have had at some point in our life, and probably have some now. I mean, it's pretty near Halloween now. What I mean is morbidity and mortality, which is a slightly less cheerful subject. The goals of this and the NTSB aren't significantly different. Ultimately, what we're trying to do is improve patient outcomes. We can do this by better procedures and by better training staff and practitioners through education process. The interesting thing is, unlike the NTSB, morbidity and mortality conferences typically stick to unusual or more complex health matters. So these tend to be things that involve maybe multiple practitioners, combinations of diseases, et cetera. So I want to take a pause, though, and look at the photo that I have up on the slide. And when I see this photo, which is fictitious, this didn't actually happen, I see a lot of hostility. I see an environment that, to me, seems rather judgy and unfriendly, and it's going to make me very uncomfortable sharing faults of any kind. I'm likely to find a way to say as little as I can about what happened and give you as little evidence as possible to hold me to account. That doesn't really match with the goal of an M&M. So it probably won't surprise any of you in the room that it resembles this more than it does the previous photo. They realized their goal was education. It was to educate practitioners to do their job better. So rather than have a situation that had a panel very focused on you, they tend to hold them in educational settings, auditoriums. And suddenly, we take a situation that before I would describe as being very full of animosity, and now fill it with curiosity. So what can we as technologists learn from other industries? I think it's safe to say we've already learned some things. Some of the things I've mentioned in those industries are things I have seen in blameless postmortem processes. We all, at the end of it, have the same concerns. We want to avoid repeating mistakes. We want to prevent mistakes whenever possible. One of the things we can learn is that at the end of it, you can't fix people. But you can fix the systems in which people operate. One of the things that postmortems do is to create history. They create history of people's actions within a system, so we can redesign systems and processes to avoid repeating the same history. There are some other ways we've already learned. So this is a fishbone diagram, is what we normally call this, and I've seen these used in tech. I was surprised in my research I found that these are used in medicine widely. The labels change because we don't have patients typically. We have customers, which arguably are similar, but there's some differences. But you can use the same process in tech, and I have used this at companies before. So we've already started to learn these things. So it would stand that we can probably learn even more. Another thing that I came across is the question of, does it matter who's present in these meetings? I'd never put a lot of thought into this maybe happening outside of tech, but I know a meeting that involves management is almost always different than one that involves the team. If you've ever presented to someone who's 3 or 4 levels away from you, if you work at a big company, or even at a small company like the very top boss, it's different than reporting to maybe your lead or to your peers. And the way you're going to communicate and the level of depth you're going to go into is going to also change. So it turns out this came up in medicine a lot, because they found as they let administrators into these meetings and hire up people, the entire event changed. They weren't learning so much as they were trying to communicate upward what happened. And that's not that beneficial if your goal is to avoid the process in the future. The other thing they did that I'm hoping to find a way to incorporate into what I do in my job is the concept of a chairperson. So it was realized within the medical community that these big postmortems would often have a lot of questions. So it's not a very different setting than we're in today, but it would be usual to have folks in the audience ask you for clarification along the way. And it's hard enough to give a presentation like this. It's harder to give a presentation like this in which you were involved in something that may be considered bad, right? You all wanted me to come here today and speak to you. This is a positive environment. I don't think any of you want me to fail, but it's hard to say the same thing during a postmortem process. It's a lot easier to feel that people are watching you and judging you. So how do we handle that? Well, we find a way to remove some of running a postmortem from the person presenting. We elect a chairperson who will help mediate the audience. And you've seen, again, a similar thing at conferences, when you have the person who's usually up front giving time cards to a speaker, but also moderating when you come to a microphone and the sort of questions you ask. And so we can do, again, the same thing in our postmortems. So how might we, as technologists, conduct a postmortem? At a high level, you can break a postmortem down to a few things. We're going to identify symptoms, we're going to identify the causes, and we're going to identify ways that they might have been obscured or harder to find. And then we're going to find a way to create action items and prevent future occurrences. And for a postmortem process to work, that last step is really important. If you don't take the time to prioritize fixing issues that were the cause of previous incidents, you're not going to gain anything from those. You're not going to learn anything from those, and you're going to repeat your mistakes. So what I have here is a rough layout of what a postmortem might look like. There's a lot of variations on this, but typically you start with a summary. And so I have an example in which the documentation for the Google Cloud Python libraries was unavailable for users. Very high level, doesn't involve time, doesn't usually involve any sort of numbers. It gives a very rough idea of what we're talking about. And if you're going through these in a big scale, it usually will jog your memory. Then we get into deeper, general ideas of the problem. So as part of the repository cleanup, an engineer with write access deleted the GitHub Pages branch. That'll take down your documentation site pretty quick. And so then the next thing we worry about is how does this impact our users? That's pretty important to us. That's why we do most everything. So during a 2-hour period, the hosted reference documentation was unavailable for the libraries. That's a pretty long time. Then we look at how did we know the documentation went down? Well, it was detected via an external customer, and then the internal teams were notified. So in the case of this, we had a GitHub issue saying, hey, your documentation seems to be down. So the delay to the initial report was 30 minutes following the start of the outage. It's fairly factual. Some of you might be thinking 30 minutes is a pretty long time to detect something. It is. We'll get back to that. And ultimately, it was resolved by republishing GitHub Pages. And this incident is pretty illustrative because it's not super technical about how to fix it or what went wrong. It's an honest mistake with a fairly obvious solution. We also tend to have very concrete timelines, down to the minute of when actions were taken, all the way through mitigation. So when we get to the post-mortem, we can understand how to repeat the good and not repeat the bad. So you can see in here that there's some gaps. You know, we have detection, we have response, and we have mitigation. So then we break it down into the what was good, what was bad, and my favorite category, how did we get lucky? So this incident, we were fairly fortunate that a user reported a GitHub issue. When we reflected on this, if they hadn't done that, I don't know how long it would have taken us to notice it, because most engineers on the team aren't visiting our documentation that frequently. And we didn't have any alerting to notice it was down. So that allowed us to fix this pretty quickly. But what went poorly? Well, the branch probably should have been protected, right? This never should have been possible. Yeah, it was an honest mistake, but the system shouldn't allow anyone to do that. We also found that our documentation is very large. So our documentation page is for all of the different Google Cloud APIs. And so it takes a while to publish. And it was hard with GitHub to understand from any sort of logging we had that it was still in the act of publishing. So it turns out we republished it multiple times, thinking that something had went wrong. And in React, we just kept restarting the timer until it was finished rendering and then giving us documentation. So where did we get lucky? Well, a member of the team had a local copy. So this really is lucky because it turns out that if we wouldn't have had this local copy, someone would have had to figure out the basic skeleton for our documentation. Nowhere else had we recorded it. Most of it's generated, but there are a few files that are handwritten and have never been changed. And so that is also a thing to get fixed, right? You want to find ways to protect lucky situations. And then we get to the end, which I think is the most important part. After all of that, we need action items. We need to find ways to stop ourselves from repeating it. These things can take a few different categories. It might be to investigate the incident more thoroughly. There might be an area within it that maybe a subject matter expert should be pulled in. You likely will have things about repairing after the incident. It's not uncommon when trying to mitigate something that we have to cut corners and take shortcuts, and then we're going to have to clean that up at some point. We want to find ways to detect future incidents, mitigate future incidents, and prevent future incidents from happening. And I find that at pretty much every job I've had, this is where the postmortem process breaks down. We don't give ourselves time to do these things, and then we end up fighting our history over and over again. And so if you prioritize this, you can really grow as a team. This is a statement I like to remind myself of, that we ultimately fail so we can learn, which is sort of flipping on its head what happens. In a former job, they like to say the phrase fail fast, which I wasn't a huge fan of. To me, fail fast implies that people intend to fail. It's not really the case. Like, no one wants to fail, right? But in failure, we can learn, and we can avoid failing in the same way again, and we can grow together. The other thing to remind yourself of is that blame isn't really any sort of deterrent or distraction from failure. If you punish a team member, it doesn't really make you move forward, and at least for me personally, it doesn't really make me feel better. Definitely not in the long term. Maybe there's some sort of joy in the short term and sort of just endorphin release that happens, but beyond that, it's not going to help you grow or actually be more satisfied in your company and your team in what you do. And what I tend to do to make myself realize that is that in the same shoes as that person, you probably already feel bad enough as it is. I know that when I'm the cause of an incident, because often in working with our software, I make mistakes too, I feel pretty bad. I don't feel that people are necessarily going to blame me, but I feel bad that I made a mistake. And so you have to kind of get past that to the point where you see that more as a way to learn and that we can be transparent with each other. The other thing that's important is to never excuse any of these failures as human error. Because the second we've done that, we've taken away an opportunity to learn. And this calls back to Jacob's talk earlier today. He had a quote up that speaks very directly to this. If we don't look at things as being a systemic issue, we avoid the ability to have a tractable long-term solution. Because you can't fire every engineer on your team that makes a small mistake. It's not going to work. You're not going to grow. And your system will still be broken, and so you'll have to fire the next engineer that makes the same mistake. So let's talk about why we probably don't want to blame in a more concrete example. Because the previous postmortem was in a mostly blameless environment. So I have a fictional GitHub issue in which apparently we found a way to light computers on fire. It's a feature. So a developer assigns this to themselves. Cool. So someone on the team's acknowledged it's happened. They know quickly it's going on. This is awesome. And then they fixed it and they closed the bug. I mean, that's good in some way, right? The computer's no longer lighting on fire. But I have no idea why we were starting computers on fire. I have no history of that. And I wrote this example from the perspective of me that if I was afraid my team was going to blame me, I'm probably not going to make it all that obvious of what I fixed and how I fixed it and that I was the one that did it in the first place. And this is what you're going to get. You're going to lack transparency, and you're going to not get any of the repeatable things we get from better postmortem processes. So I'm going to give you 3 statements that, in my opinion, show you how you can trend towards blamelessness and sort of see it in an environment. This first statement, a script is executed that deleted the production database. Doesn't involve a person, so it's blameless, right? The problem is scripts don't run themselves, right? So we all know that someone had to have done this, but we wrote the statement, so no one is included. It's blameless. This is super blameful because you're saying that someone ran a script and it deleted the database. Okay, I guess it's true, but it doesn't really communicate a blameless culture. So we can just add an engineer executed a script that deleted the production database. That seems a little better, right? At least we're admitting that someone ran it and that maybe we can find a way to fix that interaction in that process. So in a weird way, we tend to think that a passive voice means blameless. It doesn't. So consider whenever you write those statements what you're really saying. And a cool thing happens when you're truly blameless. You can write statements that look like Chris executed a script that deleted the production database. And you don't worry about it because your team doesn't really care that you did that. They care that we need to fix it so no one can ever do it again. The fact that you did it is kind of helpful when it comes to diagnosing. So if you pull up the report later and see that Chris did it, you can get coffee with Chris and talk to him about it. So passive voice isn't blameless, and eventually you might even realize you can just put names. So how do we build this? I think the first thing we need to do is create psychological safety. This is because at the end of the day, unless we feel comfortable and secure and trusted, we're not going to be able to take risks now without feeling embarrassed. And there's a project that came out of Google called Rework. It was intended for management and to sort of share how we manage teams. But they start everything from forming psychological safety. This framework believes that everything else in our workplace derives from that. And blamelessness is all about that. It's about making people feel trusted and that they can be transparent. Another thing you can do is find positive examples already in the community. So there are a lot of examples, and I can't share them all. But one that I like a lot is the Site Reliability Engineering Handbook. And so this is a bunch of SREs that have operated already. There's a lot of talking about post-mortem processes that you can dive into. But there's a lot of you in this room, and someone here, after all this, thinks this in no way applies to them. So I have some fun ideas for you. Your system doesn't break. There's probably a good chance you have very low bars. So I think you can add some 9s, and I think we can introduce some randomness into your day. There's a quote from an economist I really like, and it's, if you've never missed a flight, you're probably spending too much time in airports. And this is the idea that in a world, we deal with averages, right? So if you've never missed flights, you're probably well in the safe territory. I think the same applies to our SLAs. If you can manage to get 100% of your SLA, is it really evaluating the health and the excellence of your system, or is it just really easy to do? The other thing you can do is you can just raise your own bar and break stuff. Again, this sort of harkened back to Jacob's talk. It's really fun to devise ideas of how your system can go down and intentionally try to break it. So rather than waiting for a failure to happen, induce a failure, maybe not in production, and then see how it goes. But remind yourself over and over again that outages are going to happen and that no one on your team wanted them to do. We all want to succeed. We all want a good product. But to do that, we need to trust each other. We can't be blameful. And that's how we form better teams and better postmortems.